How's it going, everybody? Today I want to talk to you a bit about batteries. This is a Ravpower battery. It is a 12,000 milliamp hour battery that has 2.4 amps on both ports, but combined can only charge up to 3.4 amps, which means if you plugged in both, one would be 2.4 and one would be 1 amp. Or you could look at it as they'll share the 3.4 amps. And it inputs at a 2 amp capacity, so that allows fast charging. What that means is that in a couple of hours, it is able to charge this device fully. I would say maybe 5 hours or so. Now, next we have a universal power bank. A universal power bank that is 50,000 mAh. So if you look at the Ravpower, the Ravpower's mAh was about 12,000. This is 50,000. So much bigger of a power bank. But the problem with this one is that its input is only at 1 amp. So what that means is that if this power bank was 16,000 or 12,000 milliamps, it would be twice as long for it to charge versus the Ravpower in order to get that 12,000 milliamp hours. So with that said, because it's 50,000 milliamp hours, it would take very long. It takes about a day, 24 hours or whatnot to charge this battery bank full. But once it's full, it can charge one device for a very long time. That's why this battery bank is very useful in that respect, because as it becomes full, it can output at 2.1 amps. So if your device is 2 amps or whatnot, this device or this battery bank can charge for a very long time versus all these other battery banks. Now next we have is this brand, and how this one works is that it is a 10,000 milliamp hour, 1 amp input, and 2.1 amp output, and a 1 amp output. So it's very similar to this one, because this one's 2.1 amp output and 1 amp output. This one is really just about the same too. It's just they didn't classify it like that. What they did was that they just created a single plug that said, this one can only go to a max of 1 amp, and then this one can go to 2.1. But Ravpower did it where both plugs can be used up to 2.1 amps, but in total it can still only be up to 3.4 amps, but for them it's only 3.1. So those are some of the differences. They all use, these two use micro USB to charge. This uses mini USB to charge, which I find is a little bit less compatible with most other stuff, which is not as great, but because the power bank is so big, it's still very useful. Now for this one, it's a 2.1 and then a 1.0 charger. There's 2 lightning bolts and 1 lightning bolt. Now these were very cheap. This is the key point about this battery that I'm holding. It was extremely cheap. It was like $5 plus a couple dollars shipping to get one, and it outputs at 2.1. And I needed multiple, so that's why it's very useful to have multiple banks, so that you can just move them around, or some need charging, some need to be replaced. So with all that said, and explaining about the different voltages and amperages that you can get out of each one, let's see if they can do what they say they would. So this is a cell phone. This is a X-Dragon digital meter. It will test the current. I want to make sure we're plugging into the double lightning bolt. And so what we see is that in this device, we're pulling about 0.8 amps into the cell phone. We're going to try another device. This brick right here charges my cell phone at 1.2 amps, which is slightly faster than with this device. So comparatively, if I was to use these battery banks to charge my phone, this brick would charge slightly faster than this brick. So let's plug that back in and try again. As you can see, it only gives out about a 0.8 amp. So we'll try the Ravpower now. And the Ravpower can pull out 1.2 to 1.3 amps. So what you're seeing is that even though there are so many differences in these power banks, and they all say that they give about 2.4, 2.1, 2.1 or whatnot amps with 5 volt, when you actually test it, there's variations in it. And what you're seeing is that the Ravpower is actually performing the best in charging this device the fastest. And we'll just double check, and we'll plug into we'll make sure that it's the 2.0 amp plug. There's 2 lightning bolts right here. And it is indeed only maxing out at 0.8 amps. Now with this brick, we see that it's tapping out at about 1.2. So the Ravpower is able to kick out about 1.29. So it's just slightly higher than this brick. But no matter which device I use, the cell phone will still be charging, but what's going on is if I decide to use this battery bank right here, the charging rate would be slower. It's also known as trickle charging or slow charging your device. All the newer devices are charging at about 2 amps or so, or 3 amps or so. So that increases productivity, in which you can just charge your phone for maybe an hour or two and it's full, and then you pick it up and you go. Of course, in the future, I would wish that it would be much shorter than that. Maybe charge your phone for 10 minutes or whatnot and it's full and you pick it up and go. I hope you enjoyed this video about battery banks and actually seeing what the difference is and testing with the meters. If you liked this video, please thumbs up. If you'd like to see more of these videos, please subscribe. Thank you so much for watching. It was my pleasure to make this video for you. I hope it was very helpful. As you can see, the power is decreasing as we are speaking, so it is not constantly drawing at 1.2. I also want to see if that is true for this Ravpower. We'll give it some time to see if it actually draws a lower current. And so the Ravpower does drop too, but it's staying at a steady 1.18, 1.17. this battery bank was dropping to about low